Hello and welcome to Out Code 2022 Day 13 and we're live. So, my Christmas tree is still broken, but I took it apart, found how to fix it, and the correct bulb should arrive tomorrow. So hopefully by day 14 or 15, Christmas tree will be back in business. Anyway, so it's been almost half of Advent. So yeah, I think the puzzles are going to start ramping up in difficulty now, which I'm not looking forward to. But at least it's the holiday, so I have time to work on them for hours if I need be. So yeah, my coding environment seems ready. Yep. And let's just vim into my input file. Awesome. Right. So I'll start day 30 and I'll see you after the time lapse. Let's go in 3, 2, 1. Okay, that's part 1 done. Yeah, I had an internet issue this morning. Some guy came to fix it, so Ethernet just cut out whilst I was trying to submit it. But well, at least I got it correct. Some really tough thinking. Yeah. I'm excited to see what part 2 has to offer though, because part 1, yeah, that completely racked my brain. So yeah, I'll see you after the time lapse after I've done part 2. Right, that's part 2 done. Took me a while to notice my logic error, but I'm pretty happy with that. So that was a good day. So let's check out the question. Day 13, distress signal. You climb the hill and again try contacting the elves. However, you instead receive a signal you weren't expecting, a distress signal. Your handheld device must still not be working properly. The packets from the distress signal got decoded out of order. You'll need to reorder the list of received packets to your puzzle input to decode the message. This handheld device just does really seem to not be working at all. Your list consists of pairs of packets. Pairs are separated by a blank line. You need to identify how many pairs of packets are in the right order. For example, blah blah blah. Packet data consists of lists and integers. Each list starts with opening square brackets and ends with closing square brackets. It contains 0 or more comma separated values, either integers or other lists. Each packet is always a list and appears on its own line. When comparing two values, the first value is called left and the second value is called right. Then, if both values are integers, the lower integer should come first. If the left integer is lower than the right integer, the inputs are in the right order. If the left integer is higher than the right integer, the inputs are not in the right order. Otherwise, the inputs are the same integer. Continue checking the next part of the input. If both values are lists, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the inputs are in the right order. If the right list runs out of items first, the inputs are not in the right order. If the lists are the same length and no comparison makes a decision about the order, continue checking the next part of the input. If exactly one value is an integer, convert the integer to a list which contains that integer as its only value, then retry the comparison. Using these rules, you can determine which of the pairs in the example are in the right order, blah blah blah. What are the indices of the pairs that's already in the right order? The first pair is index 1, second pair is index 2, and so on. In the above example, the pairs in the right order are 1, 2, 4, blah blah blah. Determine which pairs of packets are already in the right order. What is the sum of the indices of those pairs? Right, this question was kind of long and complicated. So I read this and I basically just gave up and just decided to read the entire thing. Not too much storyline, to be fair. Yeah, you kind of have to read the entire thing. Just looking at the input here, looking at my input. Reading this took a while just to try and understand it all. And then I just had to go through this again to try and understand it. It was just a really tough problem to understand. So I did spend a lot of time trying to understand it because it also looked really complicated. So I didn't want to start coding something that was perhaps based off the wrong idea. So yeah, I just wanted to ensure I was actually correct. Right, so let's look at my solution. Okay, so just inputting the input and splitting on every double line because that's the delimiter between the pairs. And then the idea is to use a recursive algorithm. That's what this function is. And for each pair, you're inputting it's really hard to explain recursion. But essentially what you're doing is you're checking each list. So initially, the list you're going to check are literally just going to be that list and that list. And you're comparing those. So A would be this first one and B would be the second one. And then you go through every item in that list and conduct these rules. So here I'm just checking if they're both an integer, then all you need to do is just check if one's greater or one's smaller. If they're both a list, you can just recursively call the same function. Whereas if one of them is an integer and the other is a list, you basically just call the same function, but you feed in the integer converted into a list. That's what I've done here. I've taken the integer AII, just converted it into a list by wrapping it in square brackets, and then I feed that into the same recursive function. And the idea basically is, you try and figure out, as soon as you're valid or invalid, you just return that. So that's what this bit does. It checks as soon as this is kind of the base case, I guess, because ultimately at its core, you are checking, you're comparing the integers together. So that's kind of the base case. And you're checking if it is valid, return 1. If it's invalid, return -1. And if it isn't, then just continue checking through the list because you assume they're the same. But if you've exhausted every item in your list, then at some point it means that one of the lists has to be longer than the other list. And I guess in this problem you have to put a lot of faith into Eric that he's designed all the puzzle inputs correctly, because you really have to believe that he's done it correct. Thankfully he obviously did because he's Eric. Because of that, we can now assume here that one of the lists has to be greater than the other one to differentiate which is better. and then you just check if the first one is, then you return 1. If the second one is long, if the second one is shorter, then you return -1. And -1 here just says it's invalid. 1, I'm just saying it's valid, and 0 is just like the default value, I guess. Yeah, 0 is the default value. So this is just returning 0. So if basically if none of the other checks have like passed positive or negative result, then you just want to return 0, because that's just kind of saying, oh, they're both equal. I'm not yet sure which one is, if it's in the correct order or not. And yeah, that's essentially what this does. It just goes through recursively every item in the list. And I mean this function, I mean this for loop, you're going through the smallest, you go through each index of the smallest list, because obviously at some point if list A is bigger than list B, but you just go through for I in range len A, then when you try to refer to BI, you're going to receive an error because it's out of range, so you have to select the smallest here, and that also helps you down here to identify if one of them is greater than the other one. Alright, so that's the recursive algorithm. Hopefully that made sense. I mean, it would make sense because it's recursion. Hopefully it made enough sense. Again, I think with recursive algorithms, it's really just looking at parameters and just coding them in. Like, don't even bother understanding it. I think with recursion, you just understand what values do I need to feed into my function, what values do I want out of my function, and what are the cases I can be given. So the values you're feeding into your function are just going to be the lists. The values you're returning is whether it's valid, invalid, or you're not sure yet. And then these are literally just the comparisons that the problem statement tells you to make. So if they're both integers, then you do this. If not, then you do these 2, these 3, blah blah blah. And yeah, like I think recursion at this core is pretty simple. It's what am I inputting into the function? What do I want as the output? And now I just have to code in the comparisons and the checks I want to make into the function. And I think when you distill recursion down to those ideas, it gets much easier. Because, you know, if you remember this from day 7 earlier this year, I said pretty much the same thing in day 7. I just said, oh, okay, I'm just going to now copy exactly what the problem statement asks for within the function. Because the problem statement gives you the code gives you what you're meant to do, right? It's just a matter of you doing it. And then with recursion, it literally is just a matter of you doing it. Because, you know, this is all of this code is literally exactly what these 4 paragraphs tell me what to do. Obviously there's a bit more logic about it and how to do recursion, but at the crux of it, that's pretty much it. And I think noticing this recursion is pretty cool, and the way to do that is just you see lists inside lists, because ultimately you're comparing 2 big lists together, and if you have nested lists inside those lists, then you need some sort of nesting in your code, and that's where recursion comes in. And yeah, this was kind of the input that shouted at me, screamed to me, you need recursion. So yeah, that's the recursive algorithm. And then this is just the last bit of code. Yeah, just going through each pair, I guess, and checking the value. And yeah, one thing I did notice, well, I didn't know until I just checked it today, just in my code at the start, you may have seen that, is that you can eval, so you have a list like that, you can eval that. See, that's just a string right now, it's useless. But you can actually eval that, and Python converts that into a list, which is pretty useful. I did not know that was a thing. But yeah, it was very useful actually to solve it. But yeah, that's pretty much all I'm doing. A and B, I'm just getting, you know, right now, X is just 2 lines. X is just a list of 2 lines, and each of those double lines is a pair. So you just need to split that pair on the lines, and then I just evaluate it to turn it into a real list. And that's what A and B now are. A is going to be the first one, B is going to be the second one. And yeah, that's pretty much it. Again, if you want to explore the code more, if I didn't explain things too well, or you want to like maybe use it yourself, then check out the description down below for a GitHub link. It'll be in the repo right there. Right, so let's move on to part 2. Part 2. Now, you just need to put all the packets in the right order. Disregard the blank lines in your list of received packets. The distress signal protocol also requires that you include 2 additional divider packets. That and that. Using the same rules as before, organize all packets, the ones in your list of received packets as well as the 2 divider packets into the correct order. Afterwards, locate the divider packets to find the decoder key for this distress signal. You need to determine the indices of the two divider packets and multiply them together. In this example, blah blah blah. Organize all of the packets in the correct order. What's the decoder key for the distress signal? Alright, yeah. So this is pretty much the same problem. It wasn't too difficult to understand, to be honest. It's really clear, really short problem again. So let's look at what I did and how I thought about doing this. So this was quite clearly like some sort of sorting algorithm necessary. I thought for like a minute about what algorithm might be better. I couldn't really think of one, so I just thought I'm just gonna like brute force it, going straight for the brute force. And yeah, that worked. I made a small logic error in my brute force. I quickly realized that and fixed it though. Well, not quickly, but I realized that soon enough and fixed it. But yeah, I think there's definitely going to be better ways to do this, but like doing special sorting algorithms. Like if you actually know sorting algorithms and how to implement them, it's probably better to do that, and runtime will also be faster, because the runtime for this code was pretty slow. But anyway, let's look at what I did. So firstly, it said to replace, like ignore the double lines, so you replace that with just single line breaks. And it also said to add in the two divider packets, so I just added in them here. Most of this code is pretty much the same. Well, I mean, this code is the same. It's this recursive function. So like the first part of this problem was recursion. The second part is sorting. Quite neat actually. So the sorting bit comes in here. The idea is pretty much you compare similar ideas before, right? Really, because like I couldn't be asked to rewrite this function. So what I'm doing is I'm comparing two packets together, and if they're in the correct order, I just keep them there. If they're in the wrong order, then I switch the two packets around. And I keep doing that, and then after I've checked every block of two packets, I then check like the alternating block of two packets and do the same thing, because like, and that's the issue I had. You'll just keep checking like these two together and these two together and these two together, and I mean that means that your pairs are sorted, right? So what I'm doing is I'm sorting the pairs, but I'm not sorting the actual like entire thing. And I mean it's a pretty big issue. And so to solve that, instead of just checking these and then these and then these, I do that. I do the entire thing, and then I check these two and then these two and then these two. So I'm alternating between checking these two and then these two and then these two and then these two. And if you keep repeating that, at some point it's going to work. It's really inefficient, but I knew it's going to work, so that's what I did. Yeah, you know, this code is just what I said in the first case, comparing these two and these two, so on. And then the second bit of the code, this bit, let me go down, this bit, that checks the alternating case. Again, I'm not going to explain that too much. That's just kind of like the rough algorithm and idea I used. Again, using deep copy here, just because when you copy lists are mutable, they mess up things in memory and whatever. So always need to deep copy the list. And the idea is, I keep repeating this sorting idea until the lists are the same. So until my new list is the same as my old list. Because if I have a list A and I sort it, the output is going to be... So if I have a sorted list called A and I sort it, the output of my sorting algorithm is going to be the same as A, because A was sorted in the first place. So even though I'm sorting it again, the output is still the same because it's already sorted. And that's essentially what this does. It checks if... Oh, I mean, if they're already sorted. If I just sorted something and it's the same result as it was before, then it was already sorted in the first place. And therefore I know I'm done. And I can just move on to the end, which is really just finding the index of these divided packets and multiplying them together, the indices. And yeah, that was my code. A quick overview of my code. As always, again, check it in the description down below if you want to go through the code, look at it more carefully, really think about what's going on. Yeah, really nice problems today. Some recursion and then some sorting algorithms. Yeah, really enjoyed that. Although it took a bit too long for part 2, I think my part 1's pretty decent. Again, it's just, when it comes to recursion, identifies recursion, then mindlessly just follow the same idea of what recursion is. And then, the really tough bit in recursion is figuring out what do I want to input, what do I want to output, and where is the actual like recursive line of my recursion function. And like those three bits are like the really tough bits to think about. But once you really distill the problem and decompose it and abstract it, you can really figure out those three answers. Or once you've done that, recursion is easy. Of course, that bit is like still pretty hard. Like finding out those 3 answers is really hard. And really like taxing on the brain. But anyway, 26 stars. I'm more than halfway through the advent calendar. I mean, it's getting close to Christmas, but also less problems, as I say. Ooh, what's this advent on the calendar? It's like some white lines, some white tilde lines. I reckon that probably represents like a waterfall. Did today's puzzle mention it? Not really. I don't know, I presume that's like a waterfall though. Like, you know, the foamy stuff you get on the waterfall. Yeah. Yeah. Okay, so let's see advent calendar. Looking even nicer. With more stars there. Slowly building up. So let's check out the leaderboard. Yeah, I mean, Bedavros is just so insanely good. Like, we're only halfway through and his lead's already massive. But yeah, I think there's pretty tight fights for these locations. And yeah. Right, let's see. 8 minutes for slowest part 1 today, and 3.5 minutes. Damn, 3.5 minutes, this guy. Recursion Pro. Good job to him. And passing, like passing was a bit of an issue today. Not too bad though. But yeah, these are some really good times. Part 2. I mean, I guess if you already had a sorting algorithm there, or you're just really good at sorting algorithms, this is feasible. But 30 minutes for the slowest. I guess it like spreads out over part 2, like versus part 1, and that's why part 2 times are always longer. I mean, I tend to take longer on part 2, because also the idea of the fact that you're modifying your part 1 code, which is pretty hard. Pretty hard to do. Anyway, yeah, these are some good times though, very good times. Impressive actually, like, yeah, these people are smart. Let's look at the private leaderboards for my school. Yeah, most people seem to have got today so far. Yeah, I'm here hanging out in 20th place. Yeah, okay, let's check out delta times. Okay, I mean, these delta times are pretty good. Yeah, I took, that's like 15-16 minutes without the talking. It's a pretty slow delta time. Because of those 1 or 2 logic errors I made. But yeah, everyone else seems to have really good delta times, which is nice to see. Right, let's check out. Oh damn, 13 minutes, that's good. Although, yeah, his delta time was a bit slow. Not as slow as mine, but a bit slow. Yeah, but I was pretty close behind actually. Nice. Yeah. Okay, in Danish. Yeah, this would be a pretty tight fight. Anyway, who stole the victory? Yeah, Anonymous just racking in these gold medals. I'm not doing pretty well, yeah. But I think Dr. Danish is more consistent. That's how he's still ahead of Abhinav. Yeah. Anyway, let's check out how, like this graph, how people's positions have varied over time. I quite like it. Yeah, I mean, you can see they're all leveling out near the top here. Yeah, they do seem to be largely leveling out. And I mean, they probably will stay like this for the rest of the year. But anyway, that is AoC 2022, day 13 done and dusted. Really nice problem. More brain-killing recursion, some random sorting algorithms, and awesome logic from me. Yeah, hope you enjoyed that. Today was pretty tough. I think it's getting tough in the past few days. So don't worry if you're struggling. It's all good. It's all about learning, having fun, looking at your stars go up and just getting better and smarter. So hopefully you enjoyed. Thank you for tuning in, and I'll see you tomorrow for day 14 with hopefully a fixed Christmas tree.